For this problem, we're going to draw a series of resonance structures for the molecule that's given. Now, the way this question was originally worded said draw all possible resonance structures, but as we've discussed previously in class, that's a fairly unrealistic thing to do. So in general, when I write problems like this for exams now, I'm usually looking for about 4 or 5 different resonance structures, and so that's what we're going to do in this case. So as we've seen many times before, one of the easiest ways to start is by taking the pi electrons in a carbonyl and shifting them up onto oxygen. That'll give us a single bond here and plus and minus charges on the oxygen and the carbon. From here, the most straightforward thing to do is to then move additional electrons toward the positive charge. And here we can do this in 2 different ways. We have an oxygen that has a lone pair right next to it. We can move those over. Gives us a positive charge on this oxygen because it now has too many bonds. Negative charge stays here. Alternatively, we could have shifted the pi electrons from this double bond up. Let's fix that. That gives us a new pi bond here and a plus charge down here next to the nitrogen. As above, we now have a positive charge that's both next to an atom, in this case nitrogen, that has a lone pair, as well as next to another pi bond. So again, we have two options. We could have the nitrogen donate its lone pair in here. That will shift the positive charge onto nitrogen. Like that. Alternatively, we could have used these pi electrons to shift to that positive charge as well to give us one final resonance structure. Positive charge ends up here, and the nitrogen is unchanged. So overall, we have 5 important resonance structures as we've drawn here.